let's use the Chinese remainder theorem again. This time, though, I'm with mod 13 and mod 15. If I wanted to draw all of the possibilities, I would need to have lots and lots of possibilities, because 13 times 15 is very large. 5, 3 is 15, 6, 1, 3, 195. So it would not be a good idea to draw all the possibilities in the first numbers from 0 to 194, and then to look for 3, 7. There is a faster way. And to show the faster way, it will use some of the ideas of the multiplicative inverse, which we talked about earlier. But the first thing is to find a better way to look for what x might be. Right now, x is just any number. But we have a 13 and we have a 15. If you choose a certain kind of x, we could look for x, which looks like 13 times some a plus 15 times some b. Let's look for a and b. That would be good choices here. Why is this a good idea? Well, because if I'm looking at what this is, mod 13, the 13 disappears. I have 13a. So if I go mod 13, this x is just 15b. And mod 13, I'm supposed to have something. I'm supposed to have 3. So I want this to be 3 mod 13. That means I need to find a b that makes this work. Okay? Before I do that, I want to say what the second half would look like. The second half would be thinking about what is x mod 15. Now, x, if I think about what it is mod 15, the 15b doesn't matter because I already have a multiple of 15. So that's just 13a. And that is supposed to be congruent to 7 mod 15. What this means is that instead of hunting through all of the 195 possibilities for 3 and 7, I can instead separately find the b and the a that make this work. I now have two separate problems. As soon as I find the b and the a that make this work, I can join them together like this and get x, and I'm done. So now let's do each problem one at a time. Start with the 15b is 3 mod 13. I will copy that on the next screen. I must find b so that 15b is congruent to 3 mod 13. There are many ways to do this now. I want to share the most systematic way that always works. The first is that this 15, if I want to go mod 13, I can already reduce the 15 with my 13 and say I'm solving 2b congruent to 3 mod 13, because I can just subtract away 13b here. 15 is 13 plus 2. Now, if I need to do this, it would be very convenient if I knew what was 2 inverse. So this is the general method of using the 2 inverse. Can we think of a number so that if I take the number times 2, it's congruent to 1 mod 13? This is quite simple because it's a 2. And so I can just look at it. I can tell you that if I want 1 mod 13, 14 will do. So 7 is a very good choice here. If I take 7 times 2, it's 1 mod 13. So if I have this equation that I'm trying to solve for b, it would be a good idea to multiply both sides by 7. 2b congruent to 7 times 3 mod 13. What this means, the 7 times 2 will disappear. 14, which is 1. So b congruent to 21 mod 13. 21 is a little bit large, so I'll reduce that mod 13 by subtracting another 13 to get 8. Okay. So at this point, I have many choices for b. I mean, I could choose b to be 8. I could choose b to be 21. I could even choose b to be minus 5. But any one of them will work. Let's put 8 for now. And what that means is in this choice of x, I'll put 8 here. Okay? The next thing we'll do is we need to figure out a good choice for a. So for a, I just need to have any a for which 13a is 7 mod 15. So I need any a where 13a is congruent to 7 mod 15. Again, it's convenient to do some reductions first to make the calculations easier. And I'm doing this question on purpose with all these numbers so we can try different techniques and tricks of simplifying. 13 is a very large number to be using, but minus 2 is not. What I just did is I said 13 and minus 2 have the same remainder when I divide by 15. I'm trying all the tricks to make these into small numbers. Well, now I don't like the 2. I could even say I don't like the minus sign. So let's start with getting rid of the minus sign. If I need this, it's the same thing as 2a is congruent to minus 7 mod 15. Really what I just did here is I just multiplied by the multiplicative inverse of minus 1, which is minus 1, as we saw before. So now I need to know what to multiply by. So it would be very good to find what times 2 is congruent to 1 mod 15. Again, this is relatively easy because this is a 2. And I can already see that if I chose 8, now 8 is the multiplicative inverse of 2 mod 15. So it would be good to multiply both sides of this equation by 8. And if I do that, I will have 8 times 2a congruent to 8 times minus 7 mod 15. And that means that just a is left here. So if I just a left here, because 8 times 2 is 16, reduces to 1, this is minus 56 mod 15. Minus 56, that's a terrible number. But I do know that 15 multiplies to 60. So minus 60, or adding 60, I can add 60 to both sides, and I can have a is congruent to 4 mod 15 by doing plus 60. What I just did here was plus 60. So now that's a good choice for a. Let's choose a to be 4. Going all the way back. This tells me that if I choose x to be 13a, 13 times 4 plus 15 times 8, this will work. This will be something which will give me 3 mod 13 and 7 mod 15. So let's just multiply them together and finish. 13 times 4, 3, 4, 12, 52. If I take 15 times 8, 8, 5, 40, 120. If I add these together, this tells me that 172 works. What that means, because of the Chinese remainder theorem, if I know that something works, then all of the solutions are that modulo the product of the two, of the 13 and 15. And what that means is that the solution is x is congruent to, over here, we have 172 mod 195. That's the answer. But I want to go back over the process. It may feel like it has taken a very long time to solve this problem, but that's because I wanted to let everyone try and listen and think about how you might advance as well while I explain. Let's go over the method again. It's actually very fast. The method is, I want an x which has something about 13 and something about 15. And so it would be very good to choose a multiple of 13 plus a multiple of 15. Once I have that, I just need that the 15b is the right answer modulo 13. To do that is one type of equation like this. For the other piece, mod 15, that doesn't matter, so I just have the 13a. I have another equation. I reduce one complicated pair of equations where the x is confused between the two into two separate equations which I've seen before. And whenever you see this kind of equation, where the right side is something, not necessarily 1, the most useful way to solve them, in general, is to multiply by the multiplicative inverse. And so, if you were just running through this quickly, you would actually very quickly come down to 8 for b and 4 for a, after which you put it all back and you have the choice of x. Compare that with what would happen if we had tried to draw all of the table with 195. That would be very long. You might even make a mistake. But here, we reduce to two questions which are easier. And in general, when we're solving difficult math questions, whenever we can break them into simpler questions, then we can find better ways, more correct ways, and more interesting ways to solve the problem.